we now have some new vocabulary that's going to help us classify polynomials. We're going to use that here. And we're also going to go into some other things that you have not yet seen, some vocabulary you haven't seen. And we're going to look at the graph and kind of see what we can do with it. So first of all, we're going to talk about what standard form is. And standard form of a polynomial, he said with his hands in his pockets, standard form of a polynomial is when your exponents are in decreasing order. Hands come out of the pocket for that. And we have that situation here. So x to the third, x to the second, x to the first, everything's good. It's not in factored form. Factored form would be if we had factored out an x, or factored, actually a 2x would be our greatest common factor there. You're going to see factored form later. So when I say factored form and you're like, that's not even on the page, you hold your horses. There's standard form, there's factored form, and then there's like really messed up form. This is in standard form. So when it says put this thing in standard form, it's in standard form. So standard form, done. Yes, I'm just going to put a check mark. That's kind of lame, but done. All right, the leading coefficient is the coefficient of the term that it should come in the front if you're in standard form. But if you're not in standard form, anyway, whatever it is, it's going to be the coefficient of the term with the highest exponent, and that would be this term right here. So it's going to be the 2. Leading coefficient is 2. The degree, let's see. What school did it go to? Oh, that just didn't split screen like I wanted it to. All right, that's all right. We'll be all right. So the degree of this thing is going to be the exponent, the highest exponent, which would be a 3, which means this is a cubic function. Okay, now we get to where we need to see the graph, which was why I had this thing on split screen just a minute ago. And that is going to happen again right now. There it is. Okay, so we're going to look at what this graph looks like, basically, and we're going to talk about the end behavior. Well, what's end behavior? Well, it's how you behave at the end, and I want to see how I behave at the end. So what happens on the left side, what happens on the right side? So that's what we're really going to be doing here. So I'm going to squeeze this down. You may not have that luxury on your non-touch screen devices. If you do this on your phone, you would. But I'm going to squeeze the y-axis. And when I do, I have that. Now, if you, again, don't have that luxury, you can come over here to the wrench, and you can adjust your y-axis to be a lot lower and a lot higher. Keep your x-axis the way it is in this case. Okay, so as we go to the left, what's going on? Okay, well, as we go to the left, the graph is going down. And then as we go to the right, the graph is going up. Let's put that into words using some mathematical symbols. And we'll probably kind of move it around a little bit and put some shortcuts to that notation. But as x approaches negative infinity, so let's reword that. As x goes to the left, then y is going to go down, and you can't see what I'm writing, but you will in a second. Y is going to negative infinity. So as x goes to the left, y also goes down. So as x goes to negative infinity, y goes towards negative infinity. Now what happens on the right? As we go to the right, goes up. So as x approaches positive infinity, what happens to the value of the function? It increases. So y approaches infinity. So next sentence. As x approaches positive infinity, y approaches positive infinity. There we go. We'll get out of your way so you can see. And technically those are sentences. I should put periods at the end of them. We'll take care of the punctuation in a moment. Extrema. What's extrema? Well, the obvious word that we're kind of looking at is the word extreme. Those are the highest and the lowest. Now, the highest point is infinity, but we really don't talk about that. You can't count to infinity. But we will talk about the fact that that's a high point right there. And we'll talk about the fact that that's a low point. So we have a maximum at negative 2, 44, and a minimum at 3, negative 81. All right, so let's write some stuff down. First of all, proper punctuation. And then the extrema is going to be a maximum at negative 2, 44. Negative 2, 44. There's your maximum. And we have a minimum at 3, negative 81. 3, negative 81. So those are my extrema. And if you want to call this one a max and call this one a minimum, you can. Now, I'm going to get a little bit more technical with the vocabulary here. That is not, again, the absolute maximum. The absolute maximum is infinity. Absolute minimum, negative infinity. So yeah, I can't just say that's the maximum. That is actually not the maximum. It is a maximum. It is, and I'm not writing this on the paper. I should. I will. This is a relative maximum. Relative meaning may not be the maximum, but it's the highest in its own little area. If this thing had a few more bumps to it, then I might have one maximum and then another maximum. It'd be the highest in its area, but it would not be the maximum. Okay? So I'm going to say this is a relative maximum, and this is going to be a relative, that does not start with an M, R-E-L-A-T-I-V-E, there we go. Try to salvage that spelling. And then we're also going to have an x-intercept, actually multiple x-intercepts. There's one, there's one, there's one. We're going to learn how to find those by hand. And we're going to have one and only one y-intercept, and it's at 0. So our x-intercepts are at negative 3.558, 0, and positive 5.058. And our y-intercept is at 0, only 0. If you're at the origin, it's an x and a y-intercept. So y-intercept is at 0, 0. I like coordinates. X-intercepts are at negative, what was it, 3.558? 3.558, comma 0, 0, 0, and at 5.058. 058, comma 0. Oops, 0. There we go. We'll fix that. That's a 0. That should say 0 right there. Let me scoot it over so you can see the rest of it. Get the direction right. There we go. You can see the whole thing. It's a very terrible 0, but that's a 0. One more thing I want to say on this one, and it's going to apply to all of them. If you write it like a coordinate, it really reinforces the idea that on an x-intercept, you have y values of 0, and on a y-intercept, you have an x value of 0.